Today we're going to do this section from College Algebra 3.5, and these are examples from the homework that you will be expected to do so that you'll have a guide to go by to help you do the problems. Let's look at number 1. It says solve by the method of elimination. So we're going to solve this problem by elimination. We're going to write the solution as an ordered pair. So we want to do it in a parentheses with the x first and then the y. We start out with 8x plus 4y equals negative 12, and 8x minus 4y equals negative 52. Draw a line underneath it because I see that I have a positive 4y and a negative 4y. So those are going to eliminate each other when I put them together by combining the terms. We'll have 16x when we do the x's. The y's will cancel out. And over here on this other side, both the signs are negative, so I'll end up with a negative 64 when I add those together. Dividing both sides by 16 gives me an x value of negative 4. So there's my x value for my answer. Now, I can use either equation, but I usually use this first equation. 8x plus 4y equals negative 12. And I take my negative 4 that I just got and put it in there in the equation for x. So I have 8 times negative 4 plus 4y equals negative 12. That gives me negative 32 plus 4y equals negative 12. Adding the 32 to both sides gives me 4y equals 20 because I have to subtract, the signs are different. Divide out the 4 and I get y equals 5. So my answer is negative 4, 5, written as an ordered pair. Number 2 is also to solve by the elimination. We have two equations with two unknowns. We have 8x plus 3y is equal to negative 11. Then we have 3x minus y equals negative 2. So I look at my problem to see if I can eliminate, like I could up here, with anything. And I can see that I don't have the same coefficients anywhere, but I do have a plus and a minus here. So if I could get a 3y here, I could eliminate the y. So that's exactly what I'm going to do. I'm going to take the second equation and I'm going to multiply it by 3 to eliminate the y's. Okay. I'm going to keep my first one, 8x plus 3y equals negative 11. And I'm going to multiply the second one by 3. So I have 9x minus 3y equals negative 6. Now then, when I draw my line underneath them, I can see that my y's will eliminate now. So I put my x's together and I have 17x equals negative 17. Divide out the 17 and we have x equals negative 1. Now put it back into any equation that you want. I usually use the first one. 8x plus 3y equals negative 11. And I'm going to take my negative 1 that I found out was x and put it in the x place. So now my equation will read 8 times negative 1 plus 3y equals negative 11. That's negative 8 plus 3y equals negative 11. Adding 8 to both sides gives me 3y equals negative 3. Then divide out your 3, and you have y equals negative 1. So write your answer as an ordered pair for this section. So you would have negative 1, negative 1. Okay, let's go to the next one. The next one is also elimination, but this time we have a little bit of confusion on where the x's and y's are. So let's look at this number 3. It's solved by elimination. Our first equation is 4x minus 9y equals 6.5. Notice I have a decimal in this one. In the second one, they write it as 7y minus 2x equals negative 4.5. Notice that that second one is out of order. It has the y first instead of the x. So the first thing I'm going to do is change that around. I'm going to leave this first one alone. 4x minus 9y equals 6.5. But this one, I'm going to bring my 2 in the front and make it negative 2x. You go with the sign that's in front of it. So that's going to make my 7y positive equals negative 4.5. Now, if I drew my line there, I wouldn't eliminate anything because even though I have different signs, I don't have the coefficients that are same. So I look at it to try to decide what would be the very best thing to do. And it seems like that if I take the second one and multiply the second one by 2, then I could eliminate the x's, because that would give me a positive 4 and a negative 4. So that's what I'm going to do. My first one hasn't changed. My second one now becomes negative 4x plus 14y, because I have to multiply everything by that 2, equals negative 9.0. Now when I draw my line underneath them, I can see that it's going to eliminate those x's. So those will go away, and I'll have a negative 9y and a positive 14y gives me a 5y. When I subtract these, I get negative 2.5. Now divide both sides by 5. So y would equal negative 0.5. And it's okay for it to be a decimal. I think you will probably want it to stay a decimal because you had decimals in your problem and not fractions. So now we're going to put this back into our, I'm going to choose the first equation, the one that said 4x minus 9y equals 6.5. I'm going to pick up a negative 0.5 and put it in for y. So now my problem is going to read 4x minus 9 times negative 0.5. Notice how I put that in parentheses as I substitute it back in, equals 6.5. So 4x and a negative times that negative is going to make a positive. Positive 4.5 is what that is. And now you want to subtract your 4.5 from both sides. And so you get 4x is equal to 2.0. Divide by 4. And so x is going to be 0.5. And again, on this section, they want you to write these as ordered pairs. This is actually the place where these two equations would intersect on the coordinate system. 0.5, negative 0.5. Okay, let's do number 4. It's also by elimination, but this one has another problem. We don't have anything in common with easy to eliminate by just multiplying by 1, so we have to figure out a way to eliminate something. So let's look at it. We've got 5s and 3s and 3s and 5s. So let's just pick one to eliminate. If we multiply this one by 3 to eliminate the x, then I've got to multiply the second one in order to eliminate it by -5 to eliminate the x's. I could have eliminated the y's. I just chose to eliminate the x's. So that's the plan. I'm going to multiply the first one by 3 and the second group by -5. And let's see what we get. So we have 15x plus 9y equals 114. When I multiply the 5, the 3, and the 38 by 3. In the second one, I get a -15x, which is what I wanted, minus 25y equals -210 when I multiply 3, 5, and 42 by -5. Notice how it will eliminate my x's because I have a positive 15x and a negative 15x. So those go away. I have a -25y and a 9y. I'll have to subtract those and I get a -16y equals -96. Divide both sides by -16 and I end up with y is equal to 6. Okay, now I'm going to put my y back in. My y is 6 and I'm going to pick that first one. 5x plus 3y equals 38. That's my first equation up there. I just wrote it down right here. We'll pick up the 6 right here and put it in for y. So I have 5x plus 3 times 6 equals 38. Notice how I put my substituted value in a parentheses. So I have a 5x plus 18 equals 38. Subtract 18 from both sides. And now we have 5x is equal to 20. Divide both sides by 5, and x is equal to 4. So my answer in an ordered pair would be the x value of 4 first, and then the y value of 6. So those two equations would intersect at the point 4, 6, which is called the solution to each one of those. If I put these numbers back in for x and y, it would be this number that's on the other side there. It would solve both equations. Okay, let's look to see what we have next. This number 5, I've already written out because it had multiple choice answers. And it said to give an example of a linear equation in 3 variables. So we're looking for variables of x, y, and z, and it needs to be linear, so they need to be to the first power. Doesn't need to be in a fraction because that would make it rational, not linear, and make it curved. So let's look at this. It looks like we have an x, a y, and a z in this first one. It is an equation, so it looks like this first one is going to be our answer. This is in one variable. It is an equation, but there's only one variable. This one has 2 variables, not 3. And this one is rational. These are rational equations, so those are not linear. So the answer to the first one is A. The second one says, give an example of a solution. A solution is an ordered triple with 3 variables, and it has to be linear. So we're looking for an equation like this, but we're looking for the solution, not the equation. So number 1 is an equation, not a solution. We're looking for an ordered triple. This is a system of equations, not solutions. This one is a set of numbers, not an ordered triple. And this last one is what we're looking for. It is an ordered triple. And the 4 stands for X, and the -3 stands for Y, and the 0 stands for Z. So you have an ordered triple of X, Y, and Z. Notice how you use the parentheses and not the braces. Okay, let's look at this number 7. Number 7, we're going to do by matrices. So it looks like that we already have our problem set up with 3 equations and 3 unknowns. The only thing that I need to do is to put in the coefficients of 1 if they're not there. I don't have any that's missing totally the variable, so I don't have to put in zeros, but I do have to put in the 1s. So I'll put a 1 in for X, a 1 in for Y, and a 1 in for Z. Down here, I put a 1 in front of that negative, between that negative and the X, so I have -1X. Now then, the next thing I want to do is make my matrix that I need to use. My matrix A is going to be made up of the body of the problem, and matrix B is going to be made up of the answers. So matrix A would have 1, 1, 1. Notice I'm just using the coefficients of the variables. 2, 5, 2. -1, 8, -3. Now use these brackets to indicate it's a matrix. Okay. Now then I want to find matrix B. That's the answer part. 0, -3, -11. And this is a 3 by 3. This is 3 rows. This is row 1, row 2, row 3. This is column 1, column 2, column 3. So it has 3 rows by 3 columns, rows by columns. This one has row 1, row 2, row 3, column 1. So it's a 3 by 1. Now, in order to get my X, Y, and Z, I use my matrix A, 1, 1, 1, 2, 5, 2, -1, 8, -3. And I must take the inverse of it because these are over here with the X's. To get those coefficients separated from them and get them on the right side, I use this process called an inverse. And there's a lot of mathematics behind that we are not going to discuss. But that's the way we get them to the other side, is by taking the inverse. So when I put this into my calculator, I'm looking for A inverse B. That's what I'm looking for in my blank screen. I have to put in my A and I have to put in my B in my calculator. So let's do that. Let's put in matrix A first. And so I grab my calculator and I go, you can see I've already been doing one. So I do my grab my calculator and do second matrix. Matrix is in blue above the X to the -1. That's the inverse key. So I do second matrix. Now I want to put in those numbers, so I want to edit. So I go over to edit. So I use this arrow key, and I go 2 over, and it's already highlighted on A. So I'm going to enter so that I can edit A. Okay, now then put in dimensions. Well, my dimensions are already in there, but if they weren't in there, I would do 3, enter, 3, enter, because this is a 3 by 3. Then you put in the elements. These are called elements in a matrix. Put in the elements, and you'll just carefully put in each one of the numbers as you go across. So you have 1, enter. Put an enter after each time you put in an element, and it'll skip over to the next place you're supposed to put one in. 1, 1, 1, 2, 5, 2. Use the negative that's down by the decimal point. -1, enter 8, enter -3. Be sure that you enter on the last one. If you don't, you'll have an error. Right? Now to get out of it, do second and quit. Quit is right next to second. Second, quit. And it will give you a blank screen. So now what you want to do is put in matrix B. So you follow almost the same directions. Excuse me. You do second matrix. And you want to go over to edit. And then you want to go down to B. See, we didn't have to go down on the first one. So let's see what that looks like. Second matrix, over to edit. But see, it's highlighted on A. And what you want it to highlight is B. So go down one till the B is highlighted. Then put enter. Now that will give you the place to put in the dimensions. Put in the dimensions. And then put in the elements. And you hit enter after each time you put one in. So I'm going to put my answer matrix, which is 0, enter. Oops, you see what happened is I forgot to put in my dimensions. And so I have a dimension error because it can't have a 0 as a dimension. So I'm going to quit it. Now I've got to get back in again. Second matrix, over to edit, down to B. And this time I'm going to remember to put my dimensions in. 3, 1. Now it'll let me put my elements in. 0, -3, -11. To get out of it, you do second quit. Okay. Now what I want to see on my screen is this right here. This is what I want to see on my screen. A, matrix A inverse B. So to get that answer, I do second matrix, second matrix. See it? Now, I don't want to edit it. I've already got my numbers in there. So I just hit enter. And when I do that, it'll put matrix A on my screen. What I do want to do is make sure that I put that -1 in there. So I do X to the -1 next. I just hit that key and it'll put that little -1 up there. Now I want to put in B. So second matrix and then down to B. Second matrix down to B. And look, when I put enter, it puts the B in there. Now it's just magic. You hit enter and it will give you your answer to your problem. Your X, Y, and Z is the way you've got it. And we have a matrix, 0, -1, 1. That means x is 0, y is -1, and z is 1. So I can write an ordered triple, and that's my answer. After you do it several times, it becomes pretty easy and it gets to kind of be old hat. After you get your dimensions in there, you can use them over and over again. So let's do number 8. If you have trouble or you forget the directions, just go back to that page, rewind it back to that place, and I'll go over the directions with you again, or you can contact me and I will help you. Number 8 says 9x minus y plus z equals 12. 4x plus 2y minus 3z equals -3. X minus 3y plus 2z equals 9. So the first thing you want to do is put in the coefficients that are missing. There's 1 in front of the y, 1 in front of the z, 1 in front of the x. Okay, I know that I want to get x, y, z, so I'm using matrix A, which is 9, -1, 1, 4, 2, -3, using the coefficients of the x, y, and z. I'm going to take the inverse of that and then use B to be my answer matrix. So when I get on my screen, I'm looking for A inverse B. Matrix A inverse matrix B. That's what I'm after. So let's see if we can remember how to do the directions. It's second matrix over to edit, because you've got to change the numbers from when they were in before. I want to put in A, so I enter. My dimensions are already there if I don't mess them up. So I have a 3 by 3. Now I'm ready to put in my elements. 9, enter. -1, enter. 1, enter. 4, enter. 2, enter. -3, enter. Notice I'm using the negative down by the decimal point. 1, enter. -3, enter. 2, enter. Then I do second, quit to get out of it. I'm finished doing A. Now I want to put in B, second matrix, over to edit, down to B. My dimensions are in there. They're 3 by 1s. 12, enter. -3, enter. 9, enter. Second, quit. Now I do second matrix A, inverse, second matrix B, enter. And my answer is 1, -2, 1. So that's an ordered triple for X, Y, and Z. Okay. All right, let's try number 9. Number 9 has 5x plus 3y plus z equals -18. X minus 3y plus 2z equals -18. 14x minus 2y plus 3z equals -62. So the first thing I want to do is find those places that have missing coefficients. There's one on the z and there's one on the x. I think everything else has it. Then I start putting in what I'm going to do. I want my matrix A to be 5, 3, 1, 1, -3, 2, 14, -2, 3. Well, take the inverse of that. Don't forget that little step or you'll have the wrong answer. Negative 18, negative 18, negative 62. So when I get my screen, I want it to look like matrix A inverse matrix B. All right. When we get to matrices a little bit later in the course, this will make it so much easier for you to do that section. And there's some better explanations on why this process works the way it does. So let's do second matrix, over to edit. Remember, I want to change my numbers, so I go to edit every time I have a new problem. Enter on A. I'm going to remember that it's a 3 by 3, and now I'm going to start putting in my elements. 5, 3, 1, and notice I'm entering after each time. You mess up, you'll know it because you'll have a strange answer, and you can check your matrices if you want to, just to make sure they're right if you get a strange answer. Now I'm going to put in B. It is a 3 by 1. Negative 18, enter. Negative 18, enter. Negative 62. Don't forget to enter on that last time. Now I do second matrix A inverse, second matrix B. And I get negative 3, 1, negative 6. So that is going to make the ordered triple negative 3, 1, negative 6, X, Y, and Z. Okay, let's do 2 more and we will be done with this section. Number 10, 4x plus 3y plus z equals negative 8. X minus 3y plus 2z equals negative 17. 11x minus 2y plus 3z equals negative 63. Remember, the first thing you want to do is go in and put in your coefficients for those that are missing. Then do your x, y, z. Put in your body matrix, 4, 3, 1, 1, negative 3, 2, 11, negative 2, 3. You're going to take the inverse of that, negative 8, negative 17, negative 63. Okay, I'm looking for a matrix A inverse matrix B. That's going to be my answer. Let's see if we can do it. Second matrix, over to edit because we've got to put in new numbers. And you get 4, enter 3, enter 1, enter 1, enter negative 3, enter 2, enter 11, enter negative 2, enter 3, enter. Second, quit. Second matrix. Oops, got the wrong key there. Second matrix, went to math instead. Down to B, and negative 8, enter, negative 17, enter, negative 63, enter. Second quit, second matrix, enter, second, oops, forgot to do my negative 1. If you forget that negative 1, you won't get the right answer. Second matrix, down to B, and it looks like we get negative 5, 4, and 0, which makes the ordered triple, negative 5 for the x, 4 for the y, and 0 for the z. Let's try number 11. This is our last one. They did change the variables on us. They changed to R, S, and T. Be sure that your T, you put a crook or something on it so that it doesn't look like a plus. Sometimes people get confused. So my first step is always to put in the coefficients that are missing. I think I got them. So now instead of X, Y, Z, we have R, S, and T. We do our body matrix, 5, -1, 1, 3, 2, -3, 1, -3, 2. Take the inverse of that, to x to the -1, 22, 6, 8. Okay, so now what I'm looking for on my calculator is matrix A inverse matrix B. And that's going to be some triple there. So let's try it. Second matrix over to edit, enter, 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 because it's going to be a 3 by 3. 5, enter, -1, enter, 1, enter, 3, enter, 2, enter, -3, enter, 1, enter, -3, enter, 2, enter. Second quit. Second matrix, over to edit and down to B, enter. Put the dimensions in, 22, enter, 6, enter, 8, enter. Second quit, and we do second matrix, A, inverse, second matrix, B. Now notice I can either hit the 2 or I can arrow down, and I get 402. So that makes the ordered triple 402. That's the way you want to do these 3 by 3 equations by matrices. If you want to know how to do these by elimination, there's a great video that's up there that does one by elimination from the other instructor, and the book has some great videos on how to do these by elimination. Or you can contact me and I will do a special one with you with elimination for the 3 by 3s. Hope you all have a great day. As always, contact me if you need help.